How awesome is this? So I hope you guys are enjoying it so far. We're about to take you into part 2 of the summit. Not that it's divided that way in the program, but it's at least how I think about it. But before I do, I want to give a quick plug to the Innovation Challenge tomorrow afternoon. So I think if you guys took away one thing from the discussion so far, is there a lot of really smart, intelligent, forward-looking people in this room. If you're here, you probably sub-selected into a group that cares about what we're doing, and you have you probably also heard a lot of different backgrounds, whether it's from sponsors, CMO in the area, whether it's early in the process development cycle or late, whether it's vendors, et cetera. So there's a lot of different perspectives. We heard just now about what's going to happen in regulatory or data culture. So when we think about the Innovation Challenge, it's not just about software. So for those of you that are going to participate, as you come in, there's right now on Slido, which, by the way, there's a QR code on all of your desks, if you will. You can submit ideas, but you can hack, if you will, an idea like a data model or a quality culture, whatever it is. So those are all valid ideas that you can get together, and if you have sort of passion and initiative, I encourage you to submit it on there, bring that forward, and we'll build a team around it and have some fun tomorrow. So that's my plug for it. Hopefully those of you that are going to join us can bring some forward some ideas, and we'll have a little fun. So as I mentioned, we're in part 2 here, and now we're going to get into the digital CMC ecosystem. So last year, we had a bunch of really awesome conversation. We asked a lot, is this possible? Can we connect all these systems together? Can we do this? Can we build structured data? We knew stuff was coming. This year, we have some really exciting progress to share. So we're going to go through 2 sessions. The first session here, we're going to hear from some innovative thinkers, about how they're thinking about enabling end-to-end CMC information management and broader in their portfolios. So get to hear some big picture thinking. We'll take a little break, get some coffee, and then we're going to come back and we're going to see some actual demonstrations or some discussion around things that people have built, that we've built together since the last time here. So, and then we'll take a little break and we'll take it to the soiree. So it'll be fun, nice little afternoon to wrap up here. So with that, I'm going to call our first speaker to the stage, Todd Leibrook, Digitization Portfolio Director for Siemens. Todd is the head of strategy for enterprise recipe management at Siemens, with the mission to accelerate new products to market. So welcome, Todd.
Thank you. Thank you, everybody. So first off, get ready for some disruption, because that's what we need. Wow, it's really bright. That's what we need from both industry and also from vendors and regulatory. We need disruption. So I know I'm going to eat into my time a little bit. I just want to ask one favor of the audience. I want everybody just to stand up real quick, shake it off, wake up. Come on, everybody, stand up. Please, come on. Because I want everybody awake, because I'm monotone and I'm probably going to put you to sleep, and I'm going to try not to. So, okay, thank you. Now, I'm going to go very quickly through the slides. Now, if you want the slides, I will give you a copy of the slides. But I'm going to go very quickly because I have, like most, too many slides. So first of all, what are we trying to accomplish? We're trying to understand a digital journey to accelerate NPIs to improve patient outcomes. And I like the discussion both yesterday and today, that we get so caught up in our own systems and solutions and applications that we forget about what are we really trying to do. And so I like to kind of boil it down to accelerating new product introductions. And the subtitle is Enterprise Recipe Management and Digital Labs, and you'll see why that's important. So I'm going to go through a couple of trend slides first. So first of all, key trends, I think everybody knows these. So global demographics, personalized, flexible supply chain, and evolving regulatory. And then these trends have drivers. So as the aging population and demand for new products, pace of change, and then they drive flexibility, speed, quality, sustainability, and efficiency, which then, the way that we think about it, converts to digital threads. So we found early on that we wanted to help companies improve, but we didn't have the same language. We couldn't talk the same talk across different companies, even amongst ourselves. So we're focusing on digital threads, and you can see a couple examples. So digital twins, paperless, smart bio, continuous, integrated, IoT, and so forth. And then if you go further, so we got together and we figured out, well, what are these digital threads? So we collapsed the digital, or collapsed all of these drivers into these 5 main digital threads. So in silico development, or you could consider, the R side of R&D, recipe controls for quality by design, so the D side of R&D, recipe and scale up, so tech transfer, and then global production, manufacturing, and then performance with post-market surveillance. So these are the main 5 digital threads that we're going to talk about. So, and then these are iterative because one thread affects the other thread. And there are additional threads, but these are the main threads that we're focusing on in terms of coming up with what we call a minimum viable solution to map these threads. However, before we start talking about solutions and applications and what we're going to put into cloud and how we're going to do it, we first need to map through BPMN processes, so business process modeling and notation of these digital threads. So what we've done is we have a tool that inside of Siemens that we developed where we actually have mapped all of these digital threads, and you can see they're color-coded. So on the far left, you've got the R side, and then the yellow, the D, and then the middle, the scale-up, manufacturing, and then post-market surveillance. So this is a tool that we use basically to map all of our experiences with our customers. So we've mapped the 2B best practice processes. And this map is both a data flow and a functional flow. And it shows and exposes if a company that can map to this 2B flow, if they really have the right, first of all, the right functions, the right people, the right assets, and the right understanding and the data flows. And based upon our experiences really on the discrete side, because we've been doing this for years on the discrete side, and now we've mapped over to the CPG side for the process model, and now we've mapped over to the pharma bio. And if we zoom in, here is an example of this tool for the D side of R&D. So it talks about all of the major functions on the left, and we call this our subway map with subway stops, and each of the subway stops are functions. And these functions, you can dig deep into each function, as you see on the pull down on the left. And you can define basically what are, we call it tips, trends, implications, possibilities, and lastly, solutions to deliver the functions required at that subway stop. So you can, as I explained, the last thing I mentioned was a solution. And sometimes the solution is not even a market solution, it's a functional need solution. Because you could have a custom solution, you could have a vendor-provided solution, you could have a partnered solution, you could develop it internally, a co-developed solution. So we don't want to talk about, first of all, just throwing an application in to what we think we understand as a need, because more often than not, and I would say probably everybody here knows that, you decide on an application, you put it in, and you realize, oh, well, it doesn't do this, it doesn't connect to that, it's a different data structure, it doesn't help us. And so before we ever talk about offering solutions or end-to-end, we map the end-to-end business processes. And for example, we engaged with Oliver at Bear Bio, so you heard Oliver earlier this morning. We just completed mapping Bear Biotech's end-to-end processes with a focus on digital labs. And it got so much attention that now it's going to be promoted up to Bear API and the other Bear facilities, the other Bear business units. The beauty of it is, as well, is that we have a base catalog model of 2B. We do not map the as-is. If you map the as-is, you get stuck with replicating the current problems in your future digital state, and you don't want to do that. So we don't even map the as-is. We only map the 2B. And what we do is we map the 2B from all of our experiences, and we have a base catalog. We take the catalog, we copy it over to an instance, and then we gave Bear Bio their instance of this 2B model. We then had workshops with different SMEs of the different groups. So we brought in R, we brought in D, we brought in scale up, we brought in manufacturing, quality, post-market. They all came in and we interviewed them and we asked them, is this flow correct? And believe it or not, it was about 90% correct. So our base model was 90% accurate to Bear Bio's needs. So again, by the ability of taking the base model, the base catalog, and copying it over to their instance, we then modified their instance. They get access to their instance. We trained Oliver on how to run these workshops. We ran the first one or two, and then after that, he continued to run his own workshops with his people using this cloud tool. So it was fantastic. Great experience. So, okay, well, why would you do that? What are you trying to get out of it? What it highlighted was it highlighted many gaps in the organization. Functional gaps, data flow gaps, people were doing the wrong things. There were just completely missing functions altogether. And so after confirming the mapping, you then go through a prioritization phase. So you bring everybody in, or you do it remotely, and you ask for priority of all of these functional issues, or again, trends, implications, and possibilities. And then by that prioritization, you then can take that and export it. So, I'm sorry, you actually create this 5-year digitalization program Gantt view. So now you have a Digi program, and you export that to an ALM tool, and now you execute your program in an ALM tool of all these small projects that make up and make you whole for your end-to-end BPMN. And that's so critically important that you do this step first before you start throwing applications at a need when you don't really understand the full aspect of the need. So that's the first major point that I wanted to get across today. We've executed this with J&J, Kenvue, Novozymes, just finished with Bear Biotech, and this is our path forward now, engaging all of our customers. And it's very valuable because it helps them to understand, and the ironic thing is that then they were coming to us saying, hey, we didn't realize we have this need, but oh my gosh, we have this big gap. Do you have something that can fill that gap? And some of the times we said yes, other times we said no. This is not meant to be, hey, a one-stop shop, buy everything from Siemens, because we don't have everything. And we know that. That's not why we built this. We built this to help our customers understand what they need, and then they know what to go out and look for, and we help them. So this is a system-agnostic approach to finding, what makes a customer whole to be able to do end-to-end digitalization. Okay, so that's probably the first piece, and I used up probably a lot of my time. You know these guys. So the first guy is the father of ISA 88. So he's been with me, both he and Dan have been with me for about 3 years on this journey and this strategy. You can see some of the companies that we are working with, and also kind of a maturity and a readiness model. I have a video, I'm gonna skip it. So, okay, enterprise recipe management, what is the vision? So the vision to bring drugs to market is, well, I should say, is actually accelerating new product introductions, okay? Accelerating NPIs. And then providing a scalable end-to-end solution based on Agile for mass drug and personalized. And then lastly, enable a data-driven knowledge sharing solution based on fair data principles. So we see that as really the 3 main points that we're trying to accomplish with this next approach that you're going to see. So we also are strong in digital twinning, so we really believe in modeling things before you build these things. So we have digital twins for representing molecules, products, production lines, and then the integration of those digital twins, you know, and then running those on like body sim models is the future. And digitalization starts in the lab. I mean, Siemens is strong in manufacturing, and a lot of our customers are saying, well, help us become digital. Well, we can't just start with manufacturing and shift left. It just doesn't work. You have to start in the lab. And by starting in the lab, looks something like this, is that we need a backbone for knowledge model orchestration and workflow management along the whole product life cycle. So that's the key. So you see the drug life cycle on the top, the backbone there with connections down to swim lanes, and the different color codes represent the fact that Siemens has some tools, but Siemens also doesn't have a lot of tools that are going to be needed. And so that's the representation that this, again, is a system or a vendor agnostic approach, and that we can come up with, and we have like interconnection tools to allow us to connect to other applications to either generate data, author data, or consume data. And then here's my favorite slide. I know it's probably a big slide, but to me this tells the story. And the story is, on the top you see the drug development life cycle, and then right underneath you see the process PLM layer. You cannot do this end-to-end without a process PLM. You just can't. And inside of our process PLM layer, you see 4 swim lanes. So we have a user cockpit, so that allows us to enter into the system based on function of that module and not based on the name of a module or an application. So it's just a tile that allows you to enter into the system based upon what you're trying to do and what you are as a user, which hat do you have on. And then the second one is knowledge graph. So knowledge graph plays a key part in whatever data that we generate from down below, contextualizes that data. And we've tested this out on we have a chromatography unit in our Vienna lab, and it's a real chrome unit with controls and software, because we're trying to come up with a chromatography data standard based upon using a knowledge graph. And we were successful in doing that. So this is our direction, is to use knowledge graphs to represent the process flow. And then if you can represent and model the process flow through knowledge graphs, then when you store the data into the database, it gets stored through the knowledge graph in a contextualized fashion, so it's very easy to mine the data after. Then you have the PLM layer. So the PLM layer is more the workflow layer. So again, you see project management, product and process design, and then you come down to the next block. And this is where our focus is right now, is digital lab. And digital lab is where we have to start. And we start with this product and process development, the PD process, which is our product that we just acquired roughly a year ago called RiffnX. And Riffn helps us to define this PD recipe. We've heard a lot about contextualization and data structure, and this is exactly what this tool is giving us. And if you look at that block where it says PD recipe, you'll see the key components that have to go into a CMC module. You'll see CPPs, CQAs, formula, BOP, BOM, and context. And that's the key, those are the key data sets that we are contextualizing in that tool, and then we're pushing that tool up to CMC and up to the PLM layer, and then we're recipe transforming through the promotion into a G recipe, then to a site recipe, and then master, and then pushing into manufacturing as a control recipe. And then you may say, well, how are you doing that? Because you can't just push it, right? So the way that that's going to be done, or is being done, is we query the production equipment or the specification management portion of PLM that tells us our equipment capabilities. So we map our process actions from Riffn to the equipment capabilities, and then we have a rules engine with the capability to have AI on top for ML. And then that makes the matching of where we can take this PD recipe and where can we produce it in which manufacturing facility. And then you'll see below we have instrument data orchestration. We're pulling in ELN data, LIMS, PAT data. It's all about pulling in structured data wherever we can get it from, structured data. And then if it's not structured, then we will structure it inside of Riffin, and then we will push it up into that process PLM layer, and then we will again structure it again with knowledge graphs. So that's the main, I would say, point that I want to get across today, is that we are doing this. Customers are already on this journey with us, and it's very exciting because I think finally we figured out how to do it. We're currently doing this in a few major CPG companies, but we've also been doing this for years on the discrete side. Just a few more. So I'm just going to introduce what is RiffNX for those that don't know. It's basically a way to create a PD recipe in the lab. So it's designed for R&D scientists, and instead of just allowing them to put unstructured notes into an ELN tool, they can actually go in and actually create a workflow, very simple, very easy to use workflow, and we can either allow that to be free format workflow, or they can drag and drop standard process action block workflows. And then that's how we start the standardization of data. And then you can see, once you define that early process definition, then below it, you see the multiple lines. That's where you're running your design of experiments against that process flow. So this is not only a PD definition, it's also a DOE engine. So now we can run design of experiments against our process definition. We can get the analytical analysis outputs, and then it's iterative, you feed back. And these are just more slides on Riffin that I think we're probably out of time, but we can certainly talk more about it. But RiffNX is not an ELN, it's not a LIMS, it's really a PD tool, a product and process definition tool. And it's very unique on the market. And again, fair data. We can talk about this later, but again, process design, integration, smart data, experiments. You can use it both for exploratory and confirmatory in R&D. And I do have a case study on Novozymes. They're the largest biotech in the world, enzyme biotech in the world. They mostly sell B2B, so most people don't know their name, but they are a sister company to Novo Nordisk. So they are the world leader, and they're using our Riffin product across the whole corporation, multiple sites, multiple business units. And he always jokes, the guy that gave me this, he co-presented with me, talks about trying to build the plane while flying it. So I think it's kind of interesting. So he talks about, the key is we have to pull data out of the brain of the scientist. And that's really the challenge, is how do you pull that data or that information, that knowledge? And so it's a comparison of entity-based versus hypothesis-based. So the old way is entity-based, saying I'm just going to test this and try to test quality in. Hypothesis is more about knowing where you're headed, knowing your boundaries, and then verifying it through Riffin in the R&D lab space. Should I stop? Perfect. Thank you, everybody.
Yeah. All right. Thank you, Todd. Okay. Next up, we're going to dive into a little bit more of the lab automation side with our friends from Ziffo R&D. So we're going to call to the stage two participants. First up is Shamik Ray. Shamik is the head of quality manufacturing informatics. He has experience in implementing laboratory informatics and automations in life sciences with a background in services, consulting, and product management. He has helped numerous labs embark on their digital transformation journey. And also we have Max Peterson. Max is the lab data automation practice manager at Ziffo, responsible for helping develop strategy for their lab data automation solution. He has over 20 years of experience in informatics and simulation technologies in life sciences, chemicals, and material applications. So, gentlemen, I'll give you the clicker if you don't.
Thank you. Thank you, everyone, for the opportunity today. Glad to talk a little bit about the lab ecosystem and how we can get to a better interoperable state with lab data automation. So what we'll talk about today is look at the current ecosystem, how diverse it is, what are the challenges that are typically seen in a lab, and then also how interoperability can be achieved. Example reference architecture and some real-life use cases where this has been done and the automation has been achieved. So moving on to what the ecosystem looks like, there are several different blocks over here. These are the different systems or different processes that are typically involved in a manufacturing or a quality lab. It could be different enterprise systems like an ERP or an MES or a PLM. It could be the physical space, the labs itself, where they are located, the different geographies, the different connectivities that are there, the different request and registration systems that are involved, external systems like customer portals, and then the external partners that are there as they come into the picture. That could be academia through which you are partnering different studies, also different contract manufacturing organizations helping out in running different experiments. There's the lab informatics piece, right? So at the heart of any lab, if it's an electronic system that you're using, it's going to be something like a LIMS, an ELN, or an LES, a host of different instrumentation software, and then the connectivity and the documents that are there. So there's a lot of paper-based systems that we still use in parallel with all the electronic systems. And then there are a lot of connectivity things that are coming to the picture. It could be databases, APIs, all different types. And then finally, the people and the processes, right? We deal with a lot of different people from diverse backgrounds, different cultures, different skill sets, different levels of their knowledge of what the ecosystem is going to look like. And I'll just zoom in a little bit on the document sources and connectivity. I've just listed out some of the different file formats that we typically see. If it's a tech transfer, you would see files in Excel format, in PDF format. When you're getting a certificate of analysis, it's a PDF document, sometimes a Word document. And then when it comes to connectivity from different sources, it's all out there, OPC, APIs, web services. So we are talking about a lot of different things at the same time. However, with all of these, a lot of the different organizations still have data living in separate different systems or on paper. So data is still very siloed and boxed. Now, with this in mind, let's look at a little bit on some of the specific processes or examples around the CMC operations. So building a quality specification or building a drug substance characterization or impurities testing, right? Running a stability program. So these are some of the different workflows and processes. And on the right side, you can see, again, a lot of different systems come into picture, a lot of different files, formats, exchanges that need to happen. So as the workflows scale, so are many different systems, and there are many different touch points. So how do we solve all these challenges while still keeping the data? We have heard multiple times today, the data should be fair, the data should be easily accessible, and the data should be standardized and consistent across all different modalities and systems. So we'll look at an example reference architecture, how this can be achieved. And this is where, So this is an architecture that we have seen being successful across different organizations. And if we look at it, there are different layers. The first is the different physical systems or equipments in the labs. Then there's a middleware which connects that to the actual outputs. And then that middleware also takes care of contextualizing the data as well as introducing process models. So I'll hand over to Max at this point to talk over the reference architecture and examples.
Hey, thank you, Shamik. As Luke already said, oops, that was not what I wanted. I thought there was a pointer. So I was just going to say that my job is basically everything on the bottom and bringing it into this middleware where it says metadata contextualization, and then being able to push it into a harmonized data platform. And the reason I didn't put QBD Vision into the harmonized data platform is because obviously we want to be vendor agnostic as a services company, but also more importantly because lab data automation is of course more of a horizontal technology, right? We work on upstream problems with that, right? There's a lot of work in R&D, and to basically put this into context that what I personally, or what is pretty obvious, is that for a lot of these push-button applications that we talked about earlier, yeah, where you want to basically create business value, the metadata contextualization that we talked a lot about, right? What is the units, everything. Now, that is part of the equation, and for a lot of the R&D processes, that's enough. But when it comes to CMC and manufacturing, really the process model is what allows you to connect to these push-button applications. Yeah? If you wanted to do CPV or an APQR automation or any COA automation, you need to be able to connect the data stream that comes from the lab instruments that basically qualifies your product with the process model that will allow you, will give you an insight into what are the allowable parameter ranges for these instrument outputs. So as I said, now my job is really on the metadata contextualization side, and the reason I put in the bottom a lot of data sources that are traditionally not associated with lab data automation is that a lot of these contextualization data actually reside into these repositories, right? The way Todd drew the picture is, okay, you have your standard assays, you have chromatography systems and whatnot, but as the industry is moving more and more and we see a kind of a resurgence of automation, it's not a priori set where some of the key information to basically characterize the lab data, which is inherently linked to the sample information. This sample information, which glues everything together, is not necessarily centralized in your sample management system, in your LIMS or anywhere else, is actually becoming siloed again as we're moving to externalization, automation, and other processes. So I'm not, well, in the spirit of focusing on the how, I'm not going to really belabor the point that the lab instrument data stream is really plagued with like the diversity challenges and the dynamical challenges that really make this kind of a moving target. And I think we also talked a lot about the need for the contextualization of data, yeah, and this is all tied to verification of data and digital decoupling. We also talked about the business benefits, right, about automating processes. But what should be clear is that ultimately what this drives to is that you're going to introduce a meta or a middleware layer that can do operations on your lab data in order to provide the contextualization. Yeah, and there's, of course, the data standardization questions that we already mentioned, right? Applying the right data models to it, ontologies. There's, of course, the data standardization problem. But then more importantly, there is linking of data and knowledge work, right? And this is kind of our view that in the larger scope, lab data automation is not necessarily only a technology challenge, but it's actually just as much of a consulting or a services challenge. And on the consulting side, I was really excited to hear about data governance. And what I see in my day-to-day practice is that implementing lab data automation is kind of data governance live, yeah, in action, where you see that as I'm basically needing to aggregate data from these instruments, the metadata needs to be standardized, and it becomes really more of an organizational task to deal with this. On the change management side, it's really about the business processes, the analysis workflows, identifying the challenges and not going into what I was learned was paving cow paths, but really thinking about what are your opportunities when you're really automating lab data workflows. And then on the tech part, we're going into cloud technology, right? It's a massive data problem, right? If you think about a large organization producing all of this data, you need to be a scalable cloud architecture, has to be enterprise grade. You need to be able to qualify it. You need to be able to validate it. And then, of course, the workflow management, right? And that's where we implemented also BPMN to basically be able to map data analysis workflows or the lineage of the data in order to be able to map the data out. Right? In terms of technological challenges, of course, you have also the problem on the ground, which is creating all the connectors to the individual instruments. It's one of the big challenges to be able to talk to all of these instruments, and if needed, to standardize the data that they're outputting. But then on the other side, you have the data workflow part, right? And that is that for contextualization, you need auxiliary data, right? In chromatography, weighing, etc. And on the other side, in qPCR, for example, you have, or in other applications, you have standalone applications that the scientists or technicians will use to analyze the data, right? And it's not enough to simply pick up the raw data, but you need to also create a framework for the data reduction. And then, of course, also for all the review steps, right? So that, for example, review by exception is, of course, one of the biggest value drivers that you can achieve from automation. So 2 examples. This is basically a collaborative effort where we are basically supplementing a build-your-own effort to doing the lab automation effort. And that's where we can bring in our own technical expertise. And this is basically also where our tech stack stemmed from, by working with organizations to build out the frameworks that they need to ingest all the data and being able to push them into unified analytics frameworks. On the flip side, we also build out systems to basically go and crawl the LIMS and ELN systems to aggregate data out so that we can feed them into analytic solutions. And that's basically where also a lot of the data model work comes into play so that we can achieve harmonization. So this is all I had for you. I was told it's okay to do things short because Luke said we rather have a bit more discussion. than me blabbering on. So thanks, everybody. It was a pleasure. It's a really exciting meeting. And Luke, please take it over.
Thank you.
All right. Yes, hopefully we'll have an insightful Q&A and you guys will pepper these guys with questions. Last up in our group, but a man that needs no introduction, we heard from right before lunch and a gold sponsor of the show, Ryan Nielsen. Ryan is a life sciences global director at Rockwell Automation. He has over 17 years of experience and passion for collaborating and solving complex problems and adding value to the life sciences space. So please go ahead and join me in giving a warm welcome to Ryan to the stage.
See how that goes. Okay. Nope. I'll put it down. Sorry. Safety moment. Well, thanks. Good to see you all again. Before lunch, I kind of talked a lot about, our vision what we've done with the industry, and what I want to kind of focus now is on our forward direction. So some of the technologies and solutions I'm going to show you are more baked than others, just to kind of set the stage. Something else I talked about was that at Rockwell, we go forward with a consultative frame of mind. We want to use our technologies, our experiences to solve your problems. And what that allows us to do is to have those conversations, to learn a lot about what our customers are going through. From those discussions, we've really kind of nailed it down to 4 general areas of problems. First, one that should resonate with pretty much everyone in this room, I would assume, delays due to inefficient data flows. So every time we have to do a tech transfer, every time we have to make a change, that causes a delay. That's time, energy, and effort. And as we all know, every day that we prevent drugs getting in the market, that prevents our customers from recuperating, but also prevents patients who need these life-saving therapies and drugs. Additionally, we've learned a lot about personalized medicine. And it's not only personalized medicine, but it's a shift from very large-scale manufacturing where everyone takes the same drugs to a much smaller manufacturing scale. Now, there's a lot more of them, but it's going to cause pain from a manufacturing implication perspective. Actually, one side note, as I was practicing this, I have 2 daughters that are 8 and 10, and they're absolutely amazing. That's a fun age where they ask you so many different questions that make you think. And I was talking to my daughter, my oldest, about that statement, about personalized medicine. She's like, I don't understand. And I'm like, well, currently, if we all have a headache, we take the exact same pill. She's like, yeah. I'm like, eventually, we'll make a drug for you for that. She's like, I don't understand. I'm like, you will. It's crazy. It's awesome. As we talked about, actually, Matt talked about in the panel about workforce. We're estimating about 2 million jobs are going to be unfulfilled in 2025. That's quite a problem. So we need to be able to understand how we can do more with less with people on the operating floor and our customers in general. That'll obviously have an implication on your workforce. And finally, this is a life science community. I don't care where you are in the world, regulatory compliance is gonna come up. We've talked about it multiple times today. This is your right to work, and the inability to do that has more than just business impacts, it's your whole facility, right? So we'll talk about some of those. Don't worry, I'm not gonna go through every single one of these technologies and solutions. I will highlight some of them. But these are the things that we're working on. These are some of the technologies and solutions that we are to try to solve these problems I just explained. So as you can see, we're trying to increase speed to market, create flexible and scalable manufacturing. And again, that's not just personalized medicine. I remember when I started in this industry, I did life sciences DCS implementation. And one of the first major projects I worked on, if you all remember, plants used to be built for purpose. Plants used to make a drug. And then we had this idea, wait, I have a plant, I can make more than one drug. How do we do that, right? So we've been working on this a lot, and we're gonna have to get better at it. Workforce productivity, as I talked about, we need to make our operators and staff and everyone more efficient, doing more with less, and then how do we help with regulatory compliance? All right, I fully admit, there's a lot on this slide. I'm gonna do my best to try to give you a highlight, but this is our vision. This is our focus, this is our data flow for the industry. As I said before lunch, we are focused on solving our customers' problems as far back as R&D and discovery, all the way to commercial manufacturing, including your partners such as OEMs, CMOs, CDMOs. We sell motors and drives that help on the production floor, all the way up to and including digital solutions in your entire ecosystem. And so what I want to start with is a new product that we're working on that is called Factory Talk Data Mosaic. This, we talked about this actually, Yash's beginning statement this morning about breaking down silos. This enables consolidation of multiple complex data structures into a single unified platform. We believe this is a great solution for the industry. People are probably thinking, oh great, you combine IT and OT. We've heard that problem. We haven't solved it totally yet, but also what this does is it includes ET, and I'll explain what I mean by that in a little bit. We're really excited about this because it actually combines structured and unstructured data, and we're working for trying to match our customers' needs. So for those who aren't comfortable putting everything in the cloud, this will have an on-prem offering, can have an owner tenant and true SaaS, depending on what you need. I'm going to skip digital twin for now. We'll come back to that, but obviously, I think most people in this room know digital twin. I'll give more love to that topic. But I wanted to switch down to general recipe. If you're at the start of a greenfield or expansion, this is when you want to take all of your data together. You're going to use the things you typically use, electronic lab notebooks, your LIMS systems. But there's a new process that we're working on that Sachin is going to be talking about after this, so I'm doing my best not to take too much of his thunder. But digital process and product creation, or DPPC. And what we're really trying to do is just understand that there are so many different technologies and solutions that you need. I believe the panel said there were 600. Now, I don't know that there's true. How many we're going to be touching at this case. But the idea is that as you're planning for the future, you want to bring everything to the table at that point. And also, we always see, or I think we see this often, where people want to sever drug substance and drug product. And that's not reality, because there are technologies that cross both of those. So again, what we're trying to say is bring everything you can, make your general recipe designs for the next step as you continue this future. So let's say you've got your general recipes done. Now you're ready to either make clinical, or whatever your first step would be. Anthony's going to be talking about this new tool that we have called Digital Tech Transfer. So of course, I'm not going to try to steal too much of your thunder there, buddy, I'm sorry. But what we're trying to do here is provide the ability to transfer multiple disconnected data sources into structured digital data sets ready for consumption by DCS or MES. In other words, I think we've all seen it where you go from a lab to clinical, or stage one to the next, and you have all these different data sources, all these really great enriched areas of PDFs, Excel, whatever it may be. And wouldn't it be great if you can just put it into a tool and it spits it out that you can use it moving forward? That's what we're working on. So as we move forward into our site, that's where I think a lot of what Rockwell is known for. Allen Bradley PLCs, Plant PX from a DCS, which can provide, DCS, EMS, BMS. This is the life science world, so I get to talk in three-letter acronyms. Don't always get to do that. Above that, you can see Factory Talk Pharma Suite, which I'll talk about more, to our MES, serialization. Before I'll talk about more, that's an AR/VR product with our partner PTC, as well as ThingWorks, which is Internet of Things platform. So if you have a site and you need to either expand your capacity, whether you make a bigger site, or we use a CMO or CDMO, of course, we can use that digital tech transfer to bring those goodness over, as I'll talk about more. And of course, as Rockwell, we've been working with OEMs since the beginning of our organization over 120 years ago. So I'll talk about some tools we have working with OEMs. As you can see, there's a feedback loop, that yellow line. What we've created is, it's called Batch Performance Analytics, and what we're able to do is track the performance of these batches on an enterprise level. So comparing batches of different sites, offering a lot of insight and visibility to our customers. And last but not least, certainly on this slide, is RIM/DBQ. We've talked a lot about regulatory compliance, and I'll talk more about that. But really what we're trying to do is consolidate, analyze, and manage global regulatory info. So for submission planning, activity status, agency correspondence, and commitments for the products you make. So I'll go into some detail. I'll go through this quick for y'all, just on some of the solutions that we have. First, I did talk about said I'd get back to digital twin, I will. And one of our philosophies for a digital twin is actually, you see 3 different products in the top. Those are actually 3 different products that can be used together to provide a high fidelity digital twin for yourself. ANSYS is what we can use to simulate what's going on inside different unit operations, such as a bioreactor. Emulate 3D is an acquisition we made, so you can simulate the building itself, the production floor, so it can give you really the context of the entire environment in the building. And then FT Logic Echo is how we can simulate software control. So putting those all together, like I said, gives you a high fidelity digital twin. Now I mentioned ET. I probably should have talked to my kid about that, considering the ties to a great movie, but I didn't. And what we can do, though, actually, from an ET is engineering technology. When I started my career, I actually took a huge stack of P&IDs and made graphics. That's how I got into all this, and I liked it enough that I'm still doing it. And what I saw is that we would build these graphics, right? And then that stack of P&IDs would go in a drawer, or go into some change control, or just go away. Every time you buy a new skid from an OEM, you get this awesome 3D CAD drawing. You install a skid and you never go back to it. What we're doing at FT Data Mosaic is actually extending the life of those documents by bringing them in to data mosaics so you can put them in a three-dimensional world, and you can actually tie assets from your system to those drawings, so it can extend the life. So if you are looking at a measurement device, temperature, whatever that may be, you need to understand how it actually works on the device. You can bring up that picture, spin the bioreactor around, and see it. So it's offering an ability to extend that life for those drawings. Next, for flexible and scalable, I'm going to talk about plug and produce. As I mentioned, our history is enriched with OEM partners, and what we've seen in terms of moving forward, in terms of the need for scalability, is a lot of companies and our customers, as they're making multi-product facilities, as they're moving things around, it creates a ballroom of skid style of manufacturing. And for those who have had to do that, it's not easy to move things around, just plug it in. So what we're working with is Nimura 148 that everyone knows, or many people know, I should say. And really what this is, a good analogy is for anyone who's rented a car or used someone else's car lately, and if you have an Apple phone and that car has Apple CarPlay, you just hook it up. You don't have to pair it. There's no codes putting in anymore. It just knows your contacts. It just works. And that's what we're doing with OEMs and with our solutions. And one of the things that we're doing differently is hooking up in connectivity for DCS and MES as well. So again, making it easier to move things around and to use them. Okay, gonna go fast. As we mentioned, with productivity, trying to increase the amount of effort, increase the effectiveness of people on the floor is with AR/VR. So Euphoria has a couple different flavors. I won't go through all of them, but we all know that there's always one shift that does a turnover better. There's always one person who can walk in a room that no one else may solve the problem. They're like, that indicator's on, this is going on. I bet you have a manual valve there that needs to be opened. And somehow that person just knew. Well, with Euphoria Expert Capture, what you can do is put a halo lens on that individual, use voice commands, identify what that person's doing, and then feed that back to share that knowledge, to help other people get to that level. Also, we've probably always seen that individuals on a production floor at a site have probably 4 or 5, or however many monitors that they have at their desk, because they need to interface with so many different technologies. Well, Thin Manager is an opportunity to bring all that to one screen so you can hone in on what's important. Additionally, there's a product called Logic Pinpoint that can bring up automatically the line of code for alarm generation. So you don't have to try to spend all this time saying, I've got an alarm, what are the characteristics and why? I can bring you right there. Last but not least for this topic, at least with regulatory compliance, FactoryTalk PharmaSuite is premier MES solution in life sciences. We've been very successful with it. We're very proud of it, very excited that it can connect to so many different technologies, but we're not stopping there. We are working on a cloud native option for this, so it should be easier for companies, maybe smaller companies that don't have that infrastructure, or maybe don't have the capabilities for a full-fledged MES like some companies do. And also can allow for companies that maybe just want to focus on making drugs and not having to deal with every aspect of an MES. When you pair that with our serialization offering, it provides critical data across the value chain as it's delivered to the market. Lays foundations of data sets with a fully validated system for holistic solutions, which is a criteria and a foundation for critical areas moving forward, especially with personalized medicine, of chain identity and chain of custody. All right, I wasn't gonna skip CMC, I just wanted to save it to the end. So I wanna talk about how we can use CMC. So again, we've kind of gone over this, so you hopefully have an idea of everything of our flow and what our forward vision is. So the question is, how would technology like QBD Vision fit into this? And I'm happy to say it fits in very well. what we can do is try to bring this in earlier. Yasha said this before, bringing in quality by design. Matt, you actually said during the presentation, if you're still here, I can't see, sorry. Just starting backwards. How do we bring the risk-based design consideration to the start of the product lifecycle, to that general recipe design, bringing those things early? As we move forward in our production, we can understand the impacts key parameters may have on critical quality attributes, and we can try to understand what those changes need to be to correct those. So you can bring those in through the digital tech transfer tools to make those required changes. And finally, as you see in the feedback, or on the loop on the bottom side, interfacing with a RIMS or a DPQ. It helps report with auditors. I think Yashi actually said it really well with this, the fourth objective. If we're able to do that, we can really understand and prove that we have the control of our data and our process. So in summary, the main problem, although we do see that there's many problems that we're trying to solve, one of the ones I think that would resonate the most with this audience is speed to market through increased data flow and making that more efficient. There's a great stat that I just want to repeat to y'all, that 87% of the top 50 life science executives believe digitalization is the key to achieve higher speed while maintaining regulatory compliance. And also, as I stated before, any delay in getting these life-saving therapies to the customers is a day those individuals don't have those medicines. So we want to help them get them, because that's obviously what we're all here to do. Rockwell, as I said before lunch, we have a proven history of helping our customers achieve results, and we're adding value across the entire product line, including drug substance, drug product, on the floor, all the way to the top. And this is establishing the future digital ecosystem. QPD vision, obviously, as you all know, and have been here listening all day, enabling risk-based design from the start of the product lifecycle, bringing those things earlier, promoting quality by design, understanding the impact key parameters can have on critical quality attributes before they occur, and also, again, like I just said, providing the control of your data and process per the fourth objective. It just hit 0. Thank you all so much. I'm sure we're going to be taking some questions. Thank you.